This is kind of a fun question. It says that we have three observers, A, B, and C, and are listening to a moving source of sound. The diagram below shows the location of the wave crests of the moving source with respect to the three observers. Which of the following is true? When I look at this picture, before I even look at the answers, I look at this picture and I see that the wave crests are piled up over on this side, and they're really spread out over here. So on the inside, they're really close. On the outside, they're really spread apart. And I can see that my source at some point is going to be right here. And if they're piling up, that means I'm producing sound closer to the previous wave, which means that this source, the velocity of our source, has to be moving in this direction. All right. So let's look at our answers. The first two answers say that the wave fronts are moving faster at one place than the other. Well, the wave itself is going to be moving with the speed of sound, which for most cases around 340 meters per second if you're in the Earth's atmosphere near the Earth's surface on a normal temperature day. It's a factor of the substance that you're in. It's not a factor of how the source is moving. So it doesn't matter that the source is moving. All of these points, the sound is going to be moving the same speed. It's just that we're producing the next wave crest closer to the previous one if we're moving our source forward. Over here, the wave crest, because we're moving away, this wave crest is moving in that direction, and our source is moving the other direction, so the wave crests are going to get further apart, because we're producing them further away from the original point. So we have to ask ourselves, so where's the frequency the highest? Well, I know that for a given speed, that the wavelength and the frequency are proportional, or are in this relationship. If the wavelength is higher, the frequency is lower. Or if the frequency is higher, the wavelength is lower. So I want to find, for common velocity, I want to find where is the wavelength the shortest, and that'll give me my highest frequency. Well, the wavelength is shortest over in this area by C. And when we look at this, the wavelengths are the distance between wave crests, so it's between two of these points. Over here, it's between two of these wave crests. So this distance in all of these cases are going to be the wavelength of this wave. And the wavelength, the lower the wavelength, the shorter the wavelength, the higher the frequency.